Today we're going to talk about the next function on the list, which will be one-to-one function. And this is your module 3. And we're also going to look into how are we going to be able to get its inverse. Okay, so let's try to define first a one-to-one function. So when we say one-to-one function, this is a function where every value of your range should have exactly one value and only one in your domain. So for example, we have here our function, let's name it f, function f, and we have on the domain we have a, b, and c. Now let's say on the range we have 1, 2, and 3. So it's important to remember that in one-to-one, si domain should only have one pair sa ating range. So for example, A will have 2 as its pair. And 2 should have only A as its pair. No other else in the domain. B, if its pair is 1, then it should only be 1. And 1, its pair should only be B on the domain. C should have only 3 on the range as its pair, and at the same time 3 should only have C as its pair in the domain. That's why it's called one-to-one. Dapat they have no other pair involved. Okay, so let's take a look at some examples that we have here. The first one is the SSS number to a person. So when you will be employed soon in the future, you will be allowed or required to get an SSS number. So that SSS number will only be used by you. Hindi pwedeng there will be someone who has the same SSS number as you. If you're going to ask your parents, their SSS number are different from the SSS number of other people. Next, we have here airport and airport code. So if you're going to look at the examples on your notes, you have for Ninoy Aquino International Airport, you have MNL. For Mactan Cebu International Airport, you have CEB. For Clark, you have CRK. Now in Baguio, we also have our own airport code because we have Loacan Airport, correct? Though it's not much used, we still have our code, which is BAG. Now, if you're going to compare that to other airport codes in the world, no airport code will be the same. Therefore, this relationship is one-to-one, just like the first example about the SSS number. Next, we have here person and his or her citizenship. So, if you remember the issue of ABS-CBN, wherein the owner is said to be of dual citizenship, or he is an American at the same time he is a Filipino. And it became a ground or reason as to why they do not want to renew the franchise of ABS-CBN. So, a person can have two citizenships. So, if, for example, you are born in the US or in any other country, you can take up that citizenship. So, for example, you are born in Japan, you may become a Japanese citizen. At the same time, you are also a Filipino. So, this relationship is not considered as one-to-one because a person can have two citizenships. Next, let's have number 4, distance traveled and jeepney fare. So usually if you're going to ride jeepney, if it's short trip, it's usually 9 pesos. And for succeeding kilometers, you will have to add 20% of that. So, for example, you are riding a jeep going to La Trinidad from until KM4 from Baguio, you're going to pay 9 pesos. But if you're going to kilometer 5, you take the 20% of 9 pesos, add that, and then you will pay additional. And then pay additional again if you're going to go to kilometer 6. Now, it does look like it is a one-to-one function. However, from kilometers 1 to 4, you are going to pay 9 pesos. So that is 1, 2, 3, 4. 9 pesos. So, kilometers 1, 2, and 3, and 4 only points to one range. This is a function. However, it is not one-to-one since we have 4, 1, 2, 3, and 4 having the same amount of fare. That's why it's not considered a one-to-one function anymore. Next, we have here the relation pairing a real number and its square. So, real numbers would include integers. If we have -1 and then we have 1 here, if we're going to take the square of both those numbers, we are going to get 1. The same as if we have +2 and -2. If we're going to take the square of both those numbers, 2 times 2 is 4, -2 times -2 is also 4. So that means number 5 is not a one-to-one function, though it is a function because they point to only 2 and -2 point to only one range. So this is an acceptable function. However, it's not one-to-one anymore because the square has 2 pairs on the domain. So number 5 is not one-to-one function. Okay, to further explain how one-to-one function looks like, if it is an equation or you are going to present it on a table or you are going to present it in a graph, let's take the 2 examples that we have here. So we have f of x is equal to x squared, and the other one we have g of x is equal to x cubed. Now for x squared, we have here a table of values wherein we assigned that the value of the domain or the value of x variable is -2, -1, 0, 1, and 2. Now, if we're going to substitute -2 as the x value in our function, -2 squared, -2 squared will be +4. If it is -1, we will have 1, +1. If it's 0, it will be 0. 1 will have 1. 2 will have 4. Now, as you can observe from here on the table of values pa lang, you can already tell if the function is one-to-one. Why? Observe the range. We have 2 4s. We have 2 1s. So 4 as the range points to 2 values sa ating domain, which is -2 and +2. And also 1. The range 1 is pointing to 2 values in our domain, -1 and 1. If we're going to continue this, we will observe that it follows the pattern. Now we will have one range pointing at 2 domains. So dito pa lang we can already conclude that it is not a function Now, if we are presented with the graph of the function, we can also easily tell if it is a one-to-one function or not. So how do we determine that? We use the method which is called the horizontal line test. So if you're going to observe the purple lines that we have on the first graph, the purple lines passes at 2 points sa ating graph. If it passes at 2 or more points sa ating graph, therefore, we can already conclude that the graph is not 1 to 1. Okay, let's compare it to the second example that we have here, which is x cube. So we have the same values in our domain, which is -2, -1, 0, 1, and 2. Now, -2 cube will give us -8 because -2 times -2 is +4. 4 times -2 will give us -8. 1 cube, -1 cube is -1. 0 cube is 0. 1 cube is 1 and 2 cube is 8. So from here, we can already observe that each range has only one value in our domain and vice versa. That's why, dito pa lang sa ating table of values, we can already tell that x cube is a one-to-one function. And then, if we're going to look at the graph of x cube, you can see that it's a curve. And if you're going to draw the horizontal lines, the horizontal line only passes at 1 point sa ating graph. So wherever you are going to draw horizontal line, it passes at only 1 point sa ating graph. Kaya, x cube is considered a one-to-one function. One-to-one function. This time, let's talk about the inverse of a function. But before we do that, let's take a look at first the statement that you have in your notes. So it says there, you are aware of inverse operations like addition and subtraction. So for example, we are going to add 1 plus 3, you will get 4. Now, to undo it, we can have 4 minus 3, we will get 1, or we are going to subtract 1 from 4, we will get 3, which is these two numbers were the numbers we added a while ago. At the same time, division is also the inverse of multiplication. So if we're going to multiply 2 times 4, we will get 8. To undo that, we will have 8 divided by 2, we will get 4, which is that. Or, we're going to have 8 divided by 4, we will get 2, which is that. Okay, it's also mentioned in your notes, it says there that when you raise a number to an exponent, you can undo it by taking its root. So for example, we have 2 raised to 4. Now 2 raised to 4 is 16. To undo it, we take the fourth root of 16, we will get 2. So that is how inverse works. Now, for one-to-one functions, they also have their own inverse. So let's take a look at the example that we have here. It says, consider the functions f of x is equal to 2x minus 10 and g of x is equal to x over 2 plus 5. So we're going to solve for f of g of x and g of f of x. Let's do f of g of x first. So f of g, g will be, the function g will be substituted to the x value of function f. So function f is f of x equals, wait, that will be 2x minus 10. So the x value in our f function, we're going to replace it with the value of g of x. That will be 2 times x over 2 plus 5 minus 10. So this is the g function, which is the x in f of x. We replaced it with the value of g of x, and then now we simplify. So 2 times x over 2 is 2x over 2 plus 2 times 5 is 10 minus 10. 2 over 2 is 1 plus 10 minus 10 is 0. So f of g of x is equal to x. Now how about g of f of x? So we're going to have g of f of x. Now this time what we're going to do is we're going to get the function g. Function g is x over 2 plus 5. The x value in our function g, we're going to replace it with the value of function f. So that is 2x minus 10 plus 5. And then we add 5. So that will give us 2, and then 2x minus 10. 2 divided by 1 is 2. 2 times 5 is 10. So plus 10. Further simplify, we will have 2x minus 10 plus 10. Negative 10 plus 10 is 0 over 2. And 2 divided by 2, we will be left with x. So g of f of x is x. Now if you observe, we have the same outcome, which is x. So therefore, we can say that f of x is the inverse of g of x, and g of x is the inverse of f of x. Let's have the second example. We have here f of x is equal to x plus 1 over 2. And then we have g of x is equal to 2x plus 1. So we're going to determine if they are inverse of each other by taking the composite. So let's do f of g of x first. F of g of x. So we have their function f. It's x plus 1 over 2. We're going to replace the variable x with the value of g of x. So that will look like 2x plus 1 plus 1 over 2. And then we simplify. We get 2x and then 1 plus 1. That will give us 2 over 2. We can factor the numerator. So we'll have 2x plus 1. 2 times the quantity x plus 1 is the same as 2x plus 2 over 2. We can cancel 2 on the numerator and in the denominator. Thus, we will be left with x plus 1. X plus 1. Next, how about g of f of x? Okay, we have here function g, which is 2x plus 1. We're going to replace x with the value of f. So that will be 2 times x plus 1 over 2 plus 1. Now from here we can already cancel 2. Since we are multiplying, and remember, since they are inverse of each other, we can already cancel. X plus 1 plus 1. So we will have g of f as x plus 2. Now if you observe the outcome, f of g of x, we have x plus 1. While if we are going to do g of f of x, we get x plus 2. So therefore, f of x is not the inverse of g of x, or at the same time, g of x is also not the inverse of f of x. This time, let's talk about how we can get the inverse of one-to-one functions. Now, in your module, the steps are already mentioned there. The first step is we're going to replace f of x, if f of x is used, with y. And then, second step, we're going to interchange the variables x and y. Number 3, solve for y in the resulting equation. And number 4, replace y by f inverse of x. Okay, so let's start. With the first example, we have f of x is equal to 2x plus 6. First step, replace this with y. Y equals 2x plus 6. Second step, we interchange the variables x and y. So we will have x is equal to 2y plus 6. And next step, we are going to solve now for y. So we want y to be left on one side of our equation. So what we're going to do is we're going to transpose 6 on the other side of our equation. So we will have x, since we're going to transpose, it will become minus 6 equals to y. And then, we need to get rid of the variable or the coefficient 2 on the right side of our equation. So what we're going to do is we divide both sides by 2. Thus, we cancel 2 there, and we will be left with y equals x minus 6 over 2. After that, we replace y with this. X minus 6 over 2. So this is now the inverse of function f. Now let's find the inverse of our second example. We have there f of x is equal to the quantity x plus 1 raised to 3 plus 1. First step, replace f with y. F of x with y. So we will have it like that. Next, we exchange the variables x and y. So that will become x, and that will become y cube plus 1. Now, we want to isolate the one with the variable y on one side of our equation. So, we transpose 1. We will have x minus 1 is equal to y plus 1 cube. Next, we want to get rid of the exponent 3 there. So to do that, we need to take the cube root of this side. But we should also do on the same side, because remember, in the rule of equality, whatever you do on one side of your equation, you have to do the same on the other side of the equation. So if we're going to take the cube root of the right side of our equation, that's cube root, canceling that. And we will have y plus 1 here. And on the left side, we will have x, the cube root of x minus 1. Next, we want to get rid of 1 on the right side again. So, if we transpose, we will have the cube root of x minus 1 plus 1 equals y. Then, after that, we change y to that, and then take that cube root of x minus 1 plus 1. This is now the inverse of the function f of x. Third example, we have here f of x is equal to the cube root of the quantity negative x plus 1 over 2. First step, we replace f of x with y. So we're going to have y equals the cube root of negative x plus 1 over 2. Next, we interchange x and y. So x will be there, equals cube root of y, negative y plus 1 over 2. Next, for us to be able to solve for the value of y, we need to get rid of this cube root. So to get rid of that, we need to raise the right side of our equation to exponent 3. And again, whatever we do on one side, we also do on the other side. So we'll have x cubed here equals negative y, since that will cancel, plus 1 over 2. Next, we want to get rid of 2 here. So we multiply both sides with 2. Doing that, we cancel 2 there. We will have 2x cubed equals negative y plus 1. Next, we want to get rid of 1 there, so we can subtract 1 on both sides, or we simply say we're going to transpose. So we will have minus 1 equals negative y. Now, of course, we don't want the coefficient of y to be negative. So to get rid of that, we multiply both sides with negative 1. Thus, we will have y equals negative 2x cubed plus 1. After that, we replace y with this, and then equals negative 2x cubed plus 1. This is now the inverse of the function f of x. This time, let's discuss the graph of a one-to-one function and its inverse. So let's take a look at the first example that we have a while ago. We have f of x is equal to 2x minus 10, and we have g of x is equal to x over 2 plus 5. Now, in the table of values of f of x, we have assigned the values of x as negative 2, negative 1, 0, 1, and 2. And by doing that, we are able to obtain this y values, or these values of the range. So for example, we have 2 times negative 2, we will get negative 4 minus 10, that is 14. Now if we're going to substitute these ones, we also get these values. Now for g of x, what we did is, the range that we have here on f of x, we had it this time as the domain of g of x. And if we're going to have that as the domain of g of x, let's substitute negative 14. Negative 14 divided by 2 is negative 7 plus 5, you get 2. And this is the domain of f of x. Now, if you're going to observe the graph, we have here the graph of f of x, and then we have the graph of g of x. And as you observe, you have here the line y equals x. And these two graphs, g of x and f of x, they mirror each other. You can also see that in the intercept. So for f of x, it has the x-intercept at 5, 0. And then for g of x, it has the y-intercept at 0, 5. So we basically just exchange the values of x and y. Here on f of x, it became the y value in point A became the x value in point B. And we can also tell that by if we're going to connect these two lines or 2 points but with a line, it will form a perpendicular against the line y equals x. So when we say perpendicular, they form right angles. So that's how we can tell if the functions or the graphs of functions are inverse, or the graphs of two functions are inverse of each others. Okay, now how about this? How about the function f of x is equal to 2x cubed? Find its inverse and sketch the graph of f, that's function f, and its inverse. And we're going to find out if they are 1 to 1. So what we're going to do is, let's get the inverse first of f of x. So we have f of x is equal to 2x cubed. Now we replace f of x with y equals 2x cubed. Exchange x and y. X equals 2y cubed. Now we want to have y on one side of our equation, so we get rid of 2 on the right side. Thus we have to divide both sides by 2, cancelling the coefficient 2 of y. So we will have x over 2 equals y cubed. Then we would also like to get rid of the cube there, the exponent to which y is raised. To do that, we have to get the cube root of both sides. So we will have, that will cancel. So we will have y equals the cube root of x over 2. And then let's replace y with this. Cube root of x plus 2. Now, for us to be able to graph, we can start assigning values of x. Let's have for f of x first, x and y. Let's have negative 2, negative 1, 0, 1, and 2. Now for the x values, it's up to you to assign as long as you'll be able to graph it later. So if we'll have negative 2, negative 2 raised to 3 is negative 8 times 2, we will get 16. Negative 1 raised to 3 is negative 1 times 2, we get negative 2. 0 raised to 3 is 0 times 2 is 0. 1 raised to 3 is 1 times 2, you get 2. And 2 raised to 3 is 8 times 2, you get 16. Next, let's have those range values for, let's confirm if the one we solved for the inverse of f of x is correct by getting the range of f of x, that's negative 16. That will now become the range of the inverse. And then let's solve. So if we're going to have negative 16 there, negative 16 divided by 2 is negative 8. The cube root is negative 2. Negative 2 divided by 2 is negative 1. The cube root of negative 1 is negative 1. Now you might be wondering, cube root of a negative number, isn't that undefined? No, this is cube root. It's not square root. Okay? For 0, you get 0. 2, you get 1. And 16, you get 2. So we are able to confirm that this is the inverse of f of x. The next thing that we're going to do, that since we already have the points there, we can now start graphing. So let's do f of x first. For f of x, we have negative 2 and 16. 16 is not available here in our table, so let's not include it in the graph. For negative 1, we have negative 2. 0, 0, and then 1, 2. And then, of course, remember, 2 is 16. So, your graph should not go beyond 2 because it should reach 16 at some point. So, if we're going to graph, it should look like this. It should not touch 2 yet because the only point where your graph will touch where x values negative 2 and 2 will be when it's already at y equals negative 16 and y equals positive 16. Wait, let's improve it. Okay, now anyways, you can do better than that. Next, let's try to graph the inverse. So we have here negative 16. Unfortunately, we also don't have negative 16 in our x values. So let's have negative 2. For negative 2, we have negative 1. So it's there. Wait. Negative 1 is... No, negative 2 is at negative 1. And then 0, 0. And 2, 1. Now, of course, if we're going to graph, our graph should not also touch yet negative 2 or 2 since it will only touch those values of x once we have 16 in our x values. Unfortunately, our Cartesian plane is limited. That's why. Oops. So your graph should look like that. Now, are they inverse of each other? Now, my graph is not perfect, but if we're going to draw x equals y, okay, we can see that the graph of f of x is the mirror of its inverse and vice versa.